Hi, welcome back to DevOps presentation series, Unit 2. In the first unit, what we have discussed is about the introduction to DevOps and why DevOps. Initially, we started with the project software development lifecycle model, which is um, waterfall model, and we have seen the issues with waterfall model, that there is no quick delivery of things until the last minute. Customer won't get to see the software. So we have seen the issues. Then we have seen how Agile is transforming waterfall model into a quick delivery system. Now we also have seen that Agile has got the focus mostly on development, but not on the testing or deployment phases of the development. So, and also it also misses the one of the important phases called the build phase, because build also could take a lot of time. Now, in order to fill that gaps, DevOps come into picture. DevOps is nothing but a collaboration. It's a collection of tools, processes, and procedures, followed by two important teams: one from the software development, one from the IT. So, development team and from the IT team there is operation team. Combined together, they work on delivering the software. The reason we have to bring in ops team is because after the build stage, after the the software has to be deployed onto test machines, staging machines, and production machines. That will be handled by IT department. So we need somebody from IT department. Having a good collaboration between ops team of IT department and dev team of software development teams. So it is very, very important. That's where DevOps has come into the picture. DevOps says that in order for the quick delivery of the software, not just development practices are enough. The development is required. The speediness in development is required, and as part of development, code review process, bug fix process, all these things has to be automated. Then also it states that the build phase also should be automated. So basically, after build stage is automated, it will go to the testing stage, which also could be automated as much as possible. Then go to the deployment stage, which try the best to automate the process. When the deployment is not automated, it is called delivery. So until the final ISO or the final jar file or whatever final build is ready, that's called the delivery phase. If it is not automated, if it is automated, it is the deployment phase. After deployment phase into production, so the entire life cycle completes in a quicker, faster, and better way without much issues. That's what about DevOps. Now that's unit 1. Now in unit 2, we are going to see the software architecture. Why we have to worry about software architecture when it's more of development practice? That's the question, right? So the reason is in presentation unit 1 of the presentations also I have touched upon like a couple of places that the architecture of the software is also very, very important to make things faster. So and in this presentation series we are going to unit 2 of presentations, DevOps presentation series. We are going to discuss about what are the various software architectures that are available, which architecture fits more better into the DevOps pattern or the DevOps process, and how to what are the intricacies that are there in this process, and all those things we are going to see. So let's get into the presentation series. This is unit 2 of the DevOps presentation series. Let's go to the first slide now. So DevOps, role of an application architecture. Application architecture plays a fundamental and crucial role in the successful implementation of DevOps. That's what we just talked about. It dictates how easily an application can be developed, tested, deployed, and operated in an automated and collaborative environment. That means, so the entire sentence states that architecture is important for getting things done, like development, testing, deployment, operation, deployment, all these things to be done is very, very important. What happens if the architecture is not good? That's what we are going to see in the next slides. DevOps imposes two non-functional requirements in the architecture of the application. The application architecture should allow the application to be deployed with small but frequent changes, which is an agile philosophy. Also, give great confidence in the quality of changes that are being deployed. This is also very, very important. The reason being, it's not just quickly develop things and just put it onto the build, development, build, test, and deployment stage. It should be it should have as minimal bugs as possible, if not zero bugs, right? So a quality software should be there, and quick delivery of the software should be there. That's where the importance of architecture plays role. So DevOps has got a lot of tools, but those tools are useless if the architecture of the application is not aligned with some of these two principles that DevOps imposes, right? Let's go to the next one. Now, components of a business application. You take any business application, not even a business application, any application. Normally, there are three things in a application. In general, any business application consists of three main components. Well, it's not necessary that all three should be there in all applications, but mostly the business applications will have these three things. Now, what are those three things? Front end or client layer. In any front end, normally there would be some GUI, graphic user interface components, which contains like windows, buttons, lists, text boxes, scroll boxes, all these things, right? So UI components, they are called UI components, graphic GUI components that customer used to perform the needed business task. So it's something like this. You enter some text in a text box, you select something, check a radio button or check a check box, you do something, finally say click submit or process, so whatever. Now basically you input all this information into a form or a screen, then you ask the application to take this data and process on it, right? So that's what pretty much the front end is. Main functionalities of front end are display data, which is for getting data and stuff like that, collect user inputs, and then trigger events. Now, what is triggering events? Say after filling the entire form, you say submit, or you say process. You do something. I'll say okay. These things are actually an indication that okay, I'm done with my inputting data. You take this input data and do some processing. Give me back the results. Once the results, the input data is taken, processed, and the actual whatever outcome it could be, it is there, then we will get back to the again to the UI, where we'll see the actual output of the data. It's something like this. You have two text boxes and a button where you enter two numbers into one number in one text box, another in another text box, and you say add. So once you click add, the numbers entered in the two text boxes will be taken, added, and the result will be displayed on again back to the screen. Now the UI part is to us, and the process part is actually happening behind. That is the second step. That's called the business logic or middle tier or application layer. So basically front end is the UI, middle tier is the business logic. This component that contains core logic that processes user inputs and handles application rules. So whatever rules that needs to be happen, I just talked about like adding two numbers, which is pretty much like very simple, add two numbers, right? But there could be a lot of complex business rules could be there. Main functionalities of middle tier are to validate input, process data, and enforce business rules and workflows. Well, this is also important. Validation of input is also very, very important, because certain inputs can be validated on the front end itself, that is on the client layer. For example, you entered a name instead of a number, right? So that can be validated pretty easily on the front end itself. But you entered some number, pin code number, which is not valid in India, which may not be validated in the front end itself. It has to go to do some checks and make sure that it is there, all that stuff, right? So that's again some validation has to happen in the middle tier also, that is the application tier also, logic also. So that's where I think the middle tier comes into picture. All the business functionality, applying rules and everything is going to be there. It validates the input and apply the business rules. The third one is backend, also called data access layer. So this component that handles data storage, retrieval, and management. This tier also handles data integrity, transaction management. So basically, in most of the business systems, it's not just data is processed and business rules are applied. The data also has to be stored in the backend, like stored somewhere. So which we call it as normally as database. Of course, there are several databases, RDBS, NoSQL. We're not going to get into that right now. So database, it has to be stored in database. So that's where data access layer comes into picture, or the backend comes into picture. So as I said, there are three layers. Front end, where the user inputs, then business layer or middle tier, which actually process the data, and the back end where the data is stored basically permanently, right? So if you want to retrieve it back. So, and once retrieval happens, again it comes back to the front end in the middle tier. So this is how normally a business application happens. Now let's go to the various software architectures, popular software architectures. Well, as far as software development is concerned, there are several architectural patterns available in the industry for different variety of applications. In the context of following three, but we are going to focus on three main architectures that predominantly used in the software industry for business applications. The reason I'm saying focusing more on business is that's where a lot of applications happens. So scientific applications are more like they might follow waterfall model because everything is concrete and stuff, and of course they could also follow agile, but they don't really fit into business kind of model where we have front end, middle tier, and the back end. Now let's talk about three popular software models. One is monolithic architecture, second one is three-tier architecture, and third one is a microservice architecture. Now again, all the three architectures will have these three components that I talked about. How they are organized is where they differ. For example, let's take monolithic architecture. It combines all the three layers of an application as one component. That's what monolithic. We are going to see those architecture a little bit in detail in the next slides. Three-tier architecture. Keep three layers of the application as a separate three tiers. So that is three-tier architecture. The third one is microservice architecture. Functionality-wise three-tier architecture of components. That's pretty much microservice architecture. So what do they mean? Like in all the three, I said like there are three components are going to be there, but how they are connected is where they differ, right? So there are so many other architectures like event-driven architecture, service-oriented architecture, microkernel architecture, which is also called plugin architecture, pipe and filter architecture. So many are there, like but we are focusing on these three because they are more suited for the commercial and business applications. Let's look into each and every architecture in the next presentation. Thank you very much.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.